All right, got 7-3, day one. Be a few lessons that cover 7-3. It's a big topic. It's on solving trig equations. Okay, haven't done any of that yet. We'll take a similar approach to when we did graphing trig functions, in the sense that it'll kind of be our specific focus for a couple of weeks here. That's all. It can be a challenging thing to do, so we'll simplify it as best we can and just say, we're solving, okay? So for the next 6 lessons in the next 2 weeks and our next test, all we're doing is solving, okay? So we'll start in our first day here, and we kind of start small, and then we work our way to bigger expressions, okay? But here's, in the first part, using the unit circle, the kind of question that we're addressing. Okay, sine of theta is negative square root 3 over 2. Okay, where on the unit circle does that happen? If you were to check it, you would see 230 degrees. (300 degrees). If you want to go radians, 4 pi over 3 and 5 pi over 3. Now, we wouldn't always think about it in these terms, but technically we were solving. We had a trig equation, sine of theta equals negative square root 3 over 2, which we solved for theta. Again, typically speaking, theta is your unknown angle. And if you want to think about it that way, you could, that we're always solving, when we're solving, we're looking for the angle that's missing, okay? Same thing on this next one. We're looking for theta. That's going to be the theme all lesson, okay? Where's theta 0? Excuse me, not theta 0. Where's cosine 0? 90 degrees and 270. Go ahead right there in the unit circle and double check and verify. Yep, the x-coordinate or the cosine value at those 2 points is 0. If you want to talk in radians, 3 pi over 4, 7 pi over 4. Okay? Now we'll make some adjustments here a little later on and see that, we're not always going to be using the unit circle to solve, but technically you could say 2 things are going on that we'll talk about a lot more. We are, again, solving. We're solving a trig equation, and we're using what's called inverse trig operations to do it, okay? That is the process of saying, hey, here is a trig value. Give me the angle that has that trig value, like a tangent value of -1. 135 and 315 degrees, okay? The process of identifying those angles, which in radians would be, 3 pi over 4 and 7 pi over 4. Now we got to back up here a little bit. We got big problems over here. I was looking at the wrong part of my notes. That didn't make any sense. How about let's fix up that one? 90 degrees in radians. Yeah, that would be pi over 2. And 270. 3 pi over 2. Much better. Okay? Much better. Okay. So I show you one of each of those because notice, typically speaking, when you do an inverse and you're thinking of relating it back to not necessarily just the unit circle, but from 0 to 360 degrees, right? You're going to typically expect to get 2 answers. Okay, that's going to be really common. okay? To get your second answer, and you can verify each of these, you've got an example to go with it, okay? For sine, you take 180 minus your first answer, okay? Or if you want to talk radians, you would take pi minus your first answer, okay? That's the general rule that you could apply, and you're going to see it come up a ton, that if you want to get your second answer, all right, because this is more for like going to a calculator type of thing, which we'll get to. The unit circle, you would just kind of observe that they just work out nice, that if you do it that way, there you go, right? They fit these patterns for how you get two answers, okay? For cosine, you would take 360 degrees and subtract answer number 1. Or if you want to talk radians, for cosine, you would do 2 pi minus your first answer, right? Like if we did this off a calculator, which again we didn't need to because it was on the unit circle, the first answer would be 90 degrees. 360 minus 90 is where we would get the 270, okay? So we're kind of setting ourselves up when we're not using the unit circle. How do we know, just from like doing the number cruncher, how do we get the second answer? Because we're seeing that when we're solving a trig equation, we're typically getting two answers. That's going to continue to be the case. Now, this part can be a little bit tricky, is the 3 trig functions that we'll work with. They each have a different rule as to how you get your second answer. And that part can be a little bit tricky. Sine, cosine, tangent, right? That's why we want to get organized with those right away, so we can kind of address that that whole situation that, the rule to get the second answer for all 3 are different, okay? But you got them, okay? And those are the only 3 you'd have to know. All right, we'll dive in and do some real solving here in a minute, but just a few of this, a few of the logistics first to kind of talk about. The definitions that you just got, they're true for exact values and approximate. That'll come up with the calculator quite a bit, okay? This might be something we'll have to talk about more. But when you're solving on the calculator, you have to use the inverse trig function, right? This part can be a little bit tricky because in the problems that use the calculator, you won't see me do them today, but that's what's going on, okay? Typically on most TI calculators, you hit second and then the trig function, right? And then it's just a function. So you hit second sine, second cosine, second tangent, then just tell it the trig value that you have, and it'll give you, hey, here's the angle that you're looking for. Our answers should always be positive. If you get an angle that is negative, not a big deal. We know how to deal with this. Coterminal, right? Just do a coterminal. Never forget. You could add 360 degrees or 2 pi radians always. Okay, it wouldn't change the angle that you're at, right? It wouldn't change the trig values. 360 or 2 pi. Okay, we would never give those as our answers, nor would we ever give answers that are greater than that. So it's like starting at 0 and then all the way up to 360 degrees and 2 pi radians, but not including them. Okay, that's the only interval we give our answers. We'd be restricted to, again, 0 to 360, not including 360 if we're in degrees. 0 to 2 pi, not including 2 pi if we are in radians. 0 to 360 for degrees, 0 to 2 pi for radians. All right, let's do some real solving, right? We're getting there. Somehow I skipped ahead a slide. I don't want to be there. I want to be here. I want that other slide in a minute. Okay, so if you're going to do this on the calculator as I'm doing it, right? And I wish in this lesson that I could show you. I don't, on this presentation, have the ability to pull up my calculator that I use on the smartboard. Okay, but it's pretty straightforward. Okay, in terms of how to use it. Basically, the only thing that's going to come up is you got to find the trig, how to access the inverse trig function, which again, there's usually a feature called second, right? Because if you'll see sine, cosine, and tangent, but if that's just the regular trig function. If you hit second and then hit the trig function, you get the inverse, which would look something like this. Okay, so we do sine inverse of 0.43. Now, you'd have to mark these as sub 1 and sub 2. I always tend to do it, but you don't need to. It says to round to the nearest tenth, so you would round from your calculator that you would get 25.5. That's our first answer, okay? The missing angle is 25.5 degrees. This is where you have to apply your rule. With sine, we would take 180 minus our first answer, and then we're going to get our second, which would be 154.5. If I were to draw a little sketch of this, what's essentially going on is right over here at 25.5, right? There's theta sub 1. It's got a sine value of 0.43 over here, right? That whole thing would be theta sub 2. There's another angle, right? That's 154.5 that has that same sine value of 0.43. Now, I'm not going to draw that diagram out every time, but the reason we're getting two answers, that's what's going on, is from 0 to 360 degrees. You'll find two angles that have a sine value of 0.43, okay? So on the right here, this is literally what you'd type into the calculator. Second tangent of negative 0.8, okay? Another feature you'd want to access on your calculator is mode, right? Under mode, you can switch from radian to degrees, okay? That's something we should look at more if you're having an issue with that, because when you're telling, it's saying based on what mode you're in, it's determining what form it's going to give you the answer, right? We're in degrees right now, so when we do an inverse trig function, we're saying we want it in degrees, right? Now, here's the thing. On this one, what the calculator is going to spit back at you is 38.7. I'm like, wait a minute. It's a rule breaker for us. We don't give negative answers. We're like, hey, not a big deal. Coterminal. Add 360, right? And we get 321. .3 degrees, and there you go. Life is good. Coterminal solves everything. Okay. Case number 2. Now, I find this part right here to be one of the toughest cases that you will find, okay? So our thing for tangent says take 180 plus your first answer, okay? So tempting to go to 321.3 and say, hey, that's answer number 1. However, we have to go back to literally the number the calculator gave us, okay? Even though we didn't give that as our final first answer, to apply the rule to get the second, that is the number that we have to use. Okay? And that isn't just unique to tangent, that is always true. Okay? That is always, always, always true. Okay? Cosine or sine, I can't give it to you in any better way. There's the bell, if you're interested. By the way, given that the bells, this is being recorded on a day you don't have school. Sorry about that. It's going to ring again in 5 minutes. So I don't think we'll be done with the lesson in 5 minutes, shortly thereafter, but we're going to get buzzed again. So sorry about that. It's 7:45 if you were interested on a Friday morning. It's going to ring again at 7:50. Now, what was I saying? Oh, man. Oh, the best way I can give it to you is when you apply that rule to get the second case, you need to use the number that literally showed up on your calculator screen, okay? That's the one you have to put in. It's the only number that it'll work for. Even though 321.3 was our first answer, negative 38.7, that's the number we had to put in. All right, moving on. Inverse cosine of a third, 70.5 degrees. Boom, there's answer number 1. If you want answer number 2, with cosine, you take 360 minus our first answer, $289.5. There we go. Alrighty. So here's the thing. I don't think I'm going to get through all of day 1 today. There might actually be like a day 1 part 2. Because these are the last 3 that we're going to do. Even though if you're looking through, if you have like the notes packet, you're seeing like, wait, there's more. There is more. There's another slide of radians, but I don't know. We'll save that for a separate day and a different video. This is going to be good for today. So we're not going to deal with radians today either. Because I do want to address this case of what if you have secant, cosecant, or cotangent, okay? Make sure the trig term is isolated. We didn't have to do much with that on the others. But this is really a big thing. Once that trig term is isolated, you got to take the reciprocal of each side. Okay? Meaning, do your reciprocal trig function and the reciprocal number. All right? There's nothing to move here with secant, right? So a nice easy example here to get going. Secant is 2.5. No, that's not going to work. Take your reciprocal trig function, which for secant is cosine, and then go 1 over 2.5, right? Flip the number. Instead of 2.5 over 1, 1 over 2.5. Once we have that, we are in business. We need to do, again, this is still in degree mode, still calculator. Inverse cosine of 1 over 2.5, 66.4 degrees. Now we have back-to-back cosines going on here. The one on the last slide was 2. 360 minus 66.4. 293.6, okay? Once we had it flipped, it was all the same as the others we'd seen. No big deal, right? No big deal. But yeah, if you get secant, cosecant, or cotangent, we don't really want to mess with those, We really don't. And it's an easy fix. Just flip the number, take the reciprocal trig function, problem solved, okay? Here's one we have to do a little bit of moving terms around because, again, that trig term needs to be isolated. So over here, what that means is on the left side, I need to have cotangent of theta, and I need nothing else, right? Nothing else can be with the trig function, okay? Remember that whole 5-minute thing? I wasn't kidding. There it was. Technically, first hour just started, but it's Friday and you don't have school, so it doesn't really matter. Anyway, if cotangent's 3, tangent's a third, okay? So we are, on the calculator, we would do tangent inverse of a third, which again, we're asking the calculator, tangent value is a third, give me an angle. In degrees, give me an angle that has that tangent value. And the calculator says, oh, sure. That angle you're talking about is 18.4 degrees. And we're like, thank you very much, calculator. We have a second answer to get, but this is no problem. With tangent, we take 180. We add our first answer to get our second. $198.4. There we go. Okay. Notice on my work, I've mentioned this before on my work. If we're in degrees, I'm really only picky about the degree symbol in the final answer. It gets a little tedious and annoying, like every time, right? You put the degree symbol with the angle. You don't, right? Just if you're working in degrees and your calculator's in radian mode, make sure you get the degree symbol on your final answer. So for this problem, that would mean right here, that 18.4 has got to have degrees, and down there, 198.4 has got to have it. All right, last problem of the day, I think. Again, there's another slide to go, but I'm going to make that like day 1, part 2, because we've been hitting it pretty hard here. We've been working hard, solving a lot of trig functions. All right, we got to get that cosecant isolated. So first things first, we got to subtract 4. We have negative cosecant of theta equals 3. Divide by negative 1. And that leaves us cosecant is negative 3. Better way to do it, that means that sine is negative 1/3. And there we go. Inverse sine of negative 1/3. All right, so what happened again? Up from our calculator, we would get negative 19.5. Okay, this is a sneaky little case here. Negative 19.5. I don't know if we'll really get into discussion of why this happens. We might at some point, but I don't know. We'll see. There's some mathematical reasons as to why from time to time it does happen that we get the negative. What we got to remember, though, is we don't give that as an answer. We just coterminal. That's an answer we'll take, 340, okay? But now we're like, it's time for answer 2. We're getting answer 2, and we've only seen this one other time. We saw it a couple slides ago with tangent, right? For sine, it's 180 minus our first answer. This is that sneaky little part. What's our, quote-unquote first answer? We go back, and we have to use that number that the calculator gave us. 340.5, it's not going to work out. Okay, it would actually give you another negative answer, which we don't want. It's got to be negative 19.5. which will give us 199.5. Okay? And again, there's that one slide left, but we'll call it good. We'll leave that for a different day and a different lesson. On that next lesson, just a heads up, we're going to make the jump and start to work in radians. All that's really going to entail is switching the mode on your calculator.